We're continuing to look at solving first order differential equation by separating the variables. And as you know, you have the variable x and the variable y all mixed up together here. You need to separate them so that you have a function of y dy equals a function of x dx. And you solve. So what I want you to do now is pause the video, write this down, and go ahead with a solution. Okay, finished? Let's see how this goes. Suppose you divide by y squared minus 4. You would have 1 over y squared minus 4 on the left, and it would cancel itself on the right. dy by dx equals 1 over x. But suppose you multiply by dx. This would cancel itself on the left, and you have dx. Alright, so that's what we have. And then we can integrate both sides. Alright, so what we have here is y, 1 over y squared minus 4. How do we deal with this? From thinking about it, let us try integration by partial fractions. Alright, so the left hand side using partial fractions. And notice, sometimes when you're answering an exam question, you have to show exactly what it is you're doing. Write down all the steps, so sometimes it's good to write down some of the steps in English to show what it is you're going to do next, you know. Alright, anyway, you have 1 over y squared minus 4. That could be written as the difference of two squares. It's y plus 2, y minus 2. You remember your difference of two squares, right? The shortcut on the left, you have what it is that you square to get the left hand side, and the right, you have what it is that you square to get the right hand side. You square y to get y square, you square 2 to get 4. Alright, that's partial fraction. This is equal to a over y plus 2 plus b over y minus 2. Alright, suppose you multiply both sides by y plus 2, y minus 2. You would have 1 equal a. The y plus 2 would cancel itself, and you'd have y minus 2. If you're not sure what happened a while ago, I suggest you write it down. Multiply both sides by y plus 2, y minus 2, and you see the cancellation, and you see exactly what happened, right? Plus b, and then you would have y plus 2 here. Alright, so what happened after this now? You say, let y equal 2. You'd have 1 equal 2 minus 2, that's gone. You wouldn't have any a left. So you'd have b 2 plus 2, which is equal to 4b. So b would be what? B would be a quarter. Alright. And if you let y equal negative 2, what you'd have is 1 equal a by negative 2 minus 2 plus, well, negative 2 plus 2 is 0. So this would go. So it would be plus 0. I wouldn't even need this here. So a would be negative a quarter. Alright, so we have our a and b. So what we have there is the integral of, it would be negative a quarter over, here is what again? Y plus 2 dy plus the integral of b was a quarter, right? A quarter over, and then you have b over y minus 2. And that was equal to, what was it again? 1 over x dx. So it's 1, the integral of 1 over x dx. Alright. Now, here, this would become negative a quarter ln y plus 2 plus a quarter ln y minus 2. If you're not sure I get this, you have to remember your substitution, integration by substitution. You could let u equal y minus 2. Oh, by the way, I didn't write the dy here. You couldn't let u equal y minus 2 or u equal y plus 2 as in this case here. And then you do your substitution. And this is equal to ln x plus c. So what you get is a quarter outside the bracket. Let's put this one first. So you have ln y minus 2 minus ln y plus 2 equal ln x plus. Let us say c is ln of another number. Say ln a. Alright. We could use our knowledge of logarithm to kind of fix this up, you know. Alright, what do we do now? This is a quarter. Remember, ln y plus 2 minus ln y minus 2 minus ln y plus 2. Let's be reminded of a rule of logarithm. Suppose you have ln, where's the ln? Ln, say 5. Oh, let's put the bigger number first. Ln, let's say 8 minus ln 5. What do we get? So we get 0.47 and so on. Now, suppose we do this. We say ln, open bracket, 8 over 5, close bracket. What do we get? Same thing. See that? Because generally, if you have ln x minus ln y, it is equal to ln x over y. Alright? It's divided by y. So remember that rule of logarithm. So ln y minus 2 minus ln y plus 2 is equal to ln y minus 2 over y plus 2. Alright? Now here, ln x plus ln a. In this case, there you have an addition, and we have another part of that rule of logarithm to remember. Remember now that if you have, for example, ln 8 plus ln 5 equal, and you get 3.688 something another. That's what you get. 8 times 5 is 40. Suppose you get ln 40. Or let me just put it this way. ln, open bracket, 8 multiplied by 5 equal. You get the same thing, right? Because you have to remember that ln x plus ln y is equal to ln xy. Alright? So, ln x plus ln a is equal to ln ax. Putting it in alphabetical order. Alright? Okay. Now, we look at this, right? What we have here is going to be, oh, guess what? Suppose we multiply everything by 4. Just fixing it up, you know. Suppose we multiply everything by 4. What do we get? We're going to get ln, we get ln y minus 2 over y plus 2 equal 4 ln ax. But remember, when you have this here, ln ax, what you would have, this part would be ln ax to the power of 4. That's what you would have. Alright, you have to remember your rules of logarithm. So, this is, on the left hand side is ln y minus 2 over y plus 2 equals ln ax to the power of 4. Now, this is a to the power of 4. You can write this as ln a to the 4 x to the 4. But ln a to the 4 is another number. So call it ln b. Let's say a to the 4 is b, whatever it is. X to the 4. Now, this says ln y minus 2 over y plus 2. Suppose now, you raise each to the power. Right? You have e to the power of each. I'm going to be working now on the left hand side, so let me put a line here to separate the work. Alright, so we have e to the power of y minus 2 over y plus 2. So e to the power of y minus 2 over y plus 2. Oh, to the power of ln y minus 2 over y plus 2 equals e to the power of ln b x to the 4 equals e to the power of ln of b x to the 4. Remember, e to the power of ln, the rule of indices again, the e and the ln, they would cancel each other, leaving the number undisturbed. So you have y minus 2 over y plus 2 is equal to bx to the 4th power. Alright. So that's what you have. And you could even rewrite it. If you don't want any fractions or you want everything flat on one level, multiply both sides by y minus 2. And you write it as y plus 2, you might write it as y minus 2 equal bx to the 4 y plus 2 if you want to do that. Alright, so there we have our solution.